Okay, so this is chapter 6, video 3. So just be aware that this video is not necessary. It is kind of fun. Not necessary. I don't want people to be overly focused on this. What this does is it gives you extra practice on percent composition, which was in the first video. And it's kind of fun. The way I would do this in class, I actually have the instructions right here, is I would split the group into somewhere between 7 and 10 groups. And I'd give each group time to calculate their victims' empirical formula from the percent compositions. And then when they finished, I also recommend calculating one of victims' 2 substances because there's a tricky bit to that one. And then you would go around and talk to other groups and you'd find what all the other groups have gotten, and then the first team with the solution would have won. And I've got room for the airplane calculations. So my intent was not for you to do every one of these calculations, but just to do 1 or 2 for more practice in kind of a fun setting. So here's the scenario. Due to adverse weather conditions, a small computer plane has crashed. You and your medical team are called to the scene of the crash, and the victims are found in and around the crash site. They must be identified by substances found in their belongings or their bodies, as there was a delay in the dental record system. Had to add that in because I had a lot of people questioning that. As you begin to investigate, you realize that before the plane crashed, a murder had occurred. And then we have some passengers, which you're supposed to use is the percent compositions to determine the formulas and identities of the compounds. Then you're going to use the personal data to make victim IDs, and then you'll figure out who's murdered and who was the most probable murderer. Dum, dum, dum. And then we have just some information about the passengers. Pilot has a heart condition, so he probably has heart meds. Baker probably has some baking supplies. Someone with Diet Coke probably has something with that's naturally in Diet Coke in their system. Painful knee injury, so maybe a painkiller. A chemist, so I don't know, but they're with a cosmetic company, so maybe some kind of cosmetic samples or something they have. Bill Jackson, dealing and using drugs, so probably a drug situation with him. And then an artist, maybe some kind of art supplies. And as a note, I always want to qualify that I did not design this. I did modify it a little bit and change some of the descriptions and took out a victim or 2 to make it a little bit easier to guess a few things on it. So I did not design this whole thing. So we're going to say that you are group 1, victim 1, and that you're going to be calculating victim 1's information. So this is where, see the columns, the percent columns. So these are all meant to be percentages. If you remember your steps, you're going to write those percentages down as gram amounts. So like carbon would be 67.31 grams. Hydrogen would be written as 6.93 grams. Nitrogen would be written as 4.62 grams. And oxygen would be written as 21.1 grams. I'm going to scooch them out just a little bit to have a little bit more space. This is the point at which it would be perfect for you to pause the video and work this out yourself, remembering all of the following steps to get this person's information. Okay, so hopefully you paused it. So hopefully you have this already calculated. This wasn't a tricky one or anything. This one goes 12.01 grams. That's carbon from the periodic chart. In 1 mole. This one is 1.01 grams in 1 mole. Nitrogen is 14.07 in 1 mole. And oxygen is 16.00 grams in 1 mole. I got my calculator handy. So 67.31. Biggest problem here is making sure you don't like twist numbers around when you're putting them in your calculator. So just do a quick double check and glance at your calculator. Make sure you did actually put the numbers in that you intended to get 5.60 4, 5. So I'm putting extra digits in there. That's usually a good idea with these problems. I kind of mentioned that before because we aren't done with the math. We're stopping to write an answer down in the middle of the math. And so to remove possible rounding errors, we're putting extra digits in. This one turns out to be 6.8614. And the next one turns out to be 0.328. And then the last one, 1.31. We'll call it 88. I'll put an extra digit on him too. So then the next step is you find the smallest one. You compare all those numbers. He's definitely the smallest one. So we're dividing by him. So I'm doing all the same steps, all the same math, all at the same time. I think it's a good way to work these problems. Notice this one's going to automatically be 1. Remember, I was talking about moles, so this is 1 mole of nitrogen. And let's see. On my calculator, I can go up and grab my numbers again. So I happen to have the closest one next is the lowest one. So I'm going to do the lowest one, the 1.3188, divided by 0.3284. That gives me 4.02. So that's definitely 4.0. The only time it's kind of weird is if there's a number here that's not 1 or 9. So that one's cool. That's O. And then 6.8614 divided by 0.3284. This one I get 20. Make sure I grab that one in there right. 6814. Yeah, I get 20.9. Notice I'm not carrying these to as many digits. It's because I've actually completed the math. Like that was the math I was looking for in the last case. 5.6045 divided by 0.3284. And that one gives me 17.07. Notice I don't have anything here, so that's really great. Moles of carbon. This is moles of hydrogen. I could have actually just solved the carbon and guessed, so that's fine if you're going to do it that way too. So let's look up here and see which one this matches with. So I need carbon. I'm going to fill them in first. So that's carbon 17, hydrogen 21, nitrogen, oxygen 4. And notice that that's the cocaine. And we go and look at our descriptions. Look, here's our guy, question for dealing. So most likely this guy is Bill. I also want everyone to practice number 2. If you can practice, then you should practice both types. You switch back to blue. I'm going to do one of the number 2s. So again, I'm going to write the numbers down. I'm just going to do the top one. So 63.15 grams. Hydrogen is 5.3 grams. Oxygen is 31.55 grams. Again, stop the video, pause it, work these ones out. Alright, so here we go. The line's extended a little long. I'm going to straighten him out. I'll put these in my calculator. So 63.15 divided by 12.01. That gives me 5.2581 moles of C. And then I have 5.3 divided by 1.01, and that gives me 5.2475 moles of H. And then if we do the last one, I have 31.55 divided by 16, which gives me 1.97 moles of O. I know the moles of O rounds up, but the other ones don't. So my smallest number, again, is this one. And by the way, if you can see that one of them is the smallest number, you might want to do that math first. And then go ahead and know that you have to divide everything out by that guy. So like you might go ahead and do this one and go ahead and know that it's divided by this number. Sorry, I should have put all the digits in. I get 1, 9. So we're going to highlight that. When you divide it by itself, you get 1 mole of O, 5.2475 divided by 1.9719. That one gives me 2.66 moles of H, and then 5.2581 divided by 1.9719. All these numbers. That one also gives me make sure I put it all in there, right? Yeah. That one also gives me, funny enough, it gives me 2.67 moles of C. Anytime something ends with a 0.3 or a 0.6, either of those, you multiply by 3. That's that last fourth step that's in here. See here? 0.6, a 0.3, or a 0.6, you multiply by 3. We'll go back to this one right here. So times 3 gives me, it's 7.99, so I'm going to go ahead and say that that's 8 carbons times 3 gives me 8 hydrogens, and times 3 gives me 3 oxygens. So if I scroll up here, I'm going to fill this in as C8H8. So C8H8O3. And we look over here, and that's this one, and that's the vanilla. When you look all up there, there's probably only one that has vanilla in it. And I'll tell you the next one. I don't have this one completely all worked out to show you, but the next one is going to be the C7H8N4O2, which is the theobromine, which is found in chocolate. So notice we have vanilla and chocolate stuff. So this person right here, this is our baker, Jim. Now you would have gone around the room, gotten all of the other people's numbers. I have them all worked out at the end to show you who's got what. So if I scroll, I have an additional page added. If I go to, what's actually on 14, at the very end, whoop. So here we go. Here's our victim 3. This is Bob. If you go up and you put that formula in for Bob, we get codeine, which is a pain med. So he's going to be that athlete, the one with the injury. That's him. Victim 4 is the pilot. When you find his is nitroglycerin, which is for heart condition. It was in his blood in his pockets. Totally makes sense for it to be the pilot. Victim 5. In their luggage was found this thing right here, which was a solvent for paint. So that's the artist. But then also in their blood was found rat poison. Oh no, this is our victim. And then we've got this chemical was found in this person's blood. So that would be Diet Coke. Aspartame is in a diet drink, right? So that's our teacher. And then we have Lisa Jo Newton. And we found strychnine, which is rat poison, in her briefcase. Our chemist, oh my goodness, is the killer. Womp, womp, womp. Also noticed there was something, an ingredient in perfume that was in her luggage. So I make sure that you can see, you can print this off or however you want to see it in the notes. Or you can screenshot this to make sure that you're getting it.